Hello and welcome back. Okay, so now we are going to be discussing the elimination method, which again I do not prefer, but again this is sometimes actually really fast to do. Just depends on what equation you get. So again, we should know how this actually works, even though we can we all can actually just choose whichever method we want. But I personally, for myself, I actually prefer the substitution method. And again, the reason for that is not because I actually dislike the elimination method like in any way, but it's just that the substitution method is always consistent in the time it actually takes to find the answer out. Okay, so enough talk. So actually, first of all, let's get the general basic idea of what we're actually trying to do. So let's get our system of equations out. And again, in this case, the boxes are just going to be representing constants. So what we actually try to do in this case is we do some basic old school addition in this case. Okay, so we're going to be trying to add the a's with the a's and the b's with the b's and the constants with the constants. And just simply doing that just isn't actually going to solve the equation. But what we try to actually do is make the bottom equation or the top equation, you can actually just modify at will. What we actually try to do is make them so that when we add them together, one of the variables actually cancels out. Okay, so it disappears, so that we have one equation and one variable, and then we can solve the equation. If that is then again possible to solve the equation. So let's say that we want to cancel the a's out. Okay, so let's actually put some solid values in there. Okay, so let's add 2 on the bottom and -2 in 2 on the top and -2 on the bottom. Okay, so you actually can see that on the screen. So when we try to add this entire equation, first of all, the a's are equal to 0, and then the b's, some constant b added to constant b, assuming that it just doesn't equal to 0, it just becomes some constant b, right? And the constant and another constant added together just end up with a constant. Now at this stage, you can actually find out the value of b. Okay, you have what is the value? What is the resultant equation in this case? A constant b is equal to a constant. You can find out the value of b really easily. Just divide the coefficient of b on both sides. So what if you don't want to cancel the a's out? You want to cancel the b's? Again, same thing. Okay, you get a box A is equal to another box. Again, you can find the value of a extremely easily at this point. Okay, so let's actually say that we do the latter and we find the value of a. Okay, all we did over here from going from here to this position was that we divided the coefficient of a so that we are left with the value of a. Now what we have over here is half of the work done. We have the value of a. It is going to be a normal constant. Now what we do is now we have the choice to put this value of a in either of these two equations. Okay, we just back substitute the thing. So let's say we back substitute into the first equation. We can put this value of a into the first equation, and a constant multiplied with another constant just gives us a constant, right? So if I actually go back, okay, so a box multiplied with a, and a is actually equal to a box. So we put the value of a in. Okay, so it's going to be a box and a box. So at the end, it just simplifies to a box, right? So now we can actually solve for b, because the a has evaporated. A has become a constant. It hasn't become a constant, but we actually know the value of a, right? So we can put the value of a there, and this is what we're left with. So now we can find the value of b, because you know this is just a single equation, single variable. We can easily find the value of b. So again, when we find the value of b, what we are actually left with is b and a. So we are done, right? We have the value of a, we have the value of e, we have the solution of the system of equation. Let's actually again try to do an actual example like we always do. So let's say we have the following system of equation: 2a added to b is equal to 3, negative a negative b is equal to 2. So again, what we want to do is, in this case, because it is evident that you can cancel out the b's, so let's actually just try to eliminate the b's in this case. Okay, so let's actually do that. And again, what you have to do is just normally add the thing because it is already done for you. Again, sometimes this is the type of system of equation in which the thing is really fast to do, because it just depends on what system of equation you get. So again, let's just actually just try to solve it. So b added to a negative b just gives us a 0. So 2a and negative a just gives us an a, and 3 added to 2 gives us a 5. So we are left with a is equal to 5. Now we have found a, and you can almost see that at this point this is really fast. But again, this is inconsistent. Sometimes it's really fast, and sometimes it takes a really long time. What if we had a fraction over here? What if we had a decimal number over here? How in God's name are we going to actually do this? It gets hard, you know. So that is why I prefer the first method. But again, let's just concentrate on this method. Okay. So a is equal to 5. We have the value of a. We can now we have the liberty of putting it either in the first equation or the second equation. So let's actually put it in the second equation. It looks easy. So we put the value of a in the second equation, negative 5. Okay. So we get negative 5, negative 5. Okay. So again, we want to find the value of b, so we need to get rid of the negative 5. So we add 5 on both sides. We do that on the left hand side. It cancels out. On the right hand side, it is equal to 2 added to 5. 2 added to 5 is 5, 6, 7. We need to get rid of the 1, which is with the b, so we can multiply negative 1 on both sides. We do that, and we get b is equal to negative 7. So we have found b, and we already had found a. So in this case, we already have the solution, and you can see it was really fast this time. But this doesn't actually always happen. But you can always prefer to use this because everyone has a different way of thinking and solving problems, even the same problems. So if you prefer this method, I highly recommend that you use this method. But again, it is always beneficial to know both, because then you can see which one suits you better. Personally, for me, I already have said that many times, but the substitution method suits me better. Okay, so it all depends on you. So thank you for watching, and I really hope you learned something.